Hello students, in this video we are going to move to the section 4 properties of logarithms. In this topic we have 5 properties that we can use to solve logarithms. The first one we have product property of logarithms. Simply we can say when we have a plus between two logarithms we can multiply these numbers m and n. We can multiply them or vice versa. For example, in example 1 we have log base 4 2 plus log base 4 and 32, and it said express as a single logarithm, simplify if possible. If our bases are the same, we can multiply these two numbers here. So we can say log base 4 2 multiplied by 32, and we know that log base 4 equals 2 multiplied by 32 is 64. So log 64 equals to what? As we mentioned before, by a calculator we can immediately solve like that. Log 64 over log 4. You can skip this step and do it by a calculator. It will be log 64, close the parenthesis, divide by log 4 equals to 3. That's it. Let's solve the check it out examples. We have checked out examples. As I mentioned before, if our bases are equal, we can multiply these two numbers together. Then we can say log and 625 multiplied by 25, or you can immediately multiply it and write it. So it will be log 5 15,625. Let's do it by a calculator immediately. We can do it by a calculator. We have log 15,625 divide by log 5 equals to 6. By which rule we do this? By this rule. Log 15,625 over log 5. By this rule you can skip this step, immediately write 6. Our result is 6. As you see, our bases are equal, so we can multiply the numbers. Log 1 over 3, 27 multiplied by 1 over 9, it will be 27 divided by 9, it will be 3. So we have log 1 over 3 and 3. Here we have a note. If we have a number and it is reciprocal, or vice versa, if you have a number here and the reciprocal here, so immediately equals to -1. That's it. Let's move to the next example or next property, which is quotient property of logarithms. Here, if we have a minus between two logarithms, we are going to divide it. That's it. This is the rule. Let's solve it. How can we solve this one? As you see, we have a minus here and our bases are equal. We have a minus. If you have a minus, we are going to divide these two numbers together. So it will be log 32 over 4. We have 2 here. So 32 divided by 4 is 8. We have log 2 and 8. 2 times 2 to the power what equals to 8. We can solve it by a mental math. So 2 to the power 3. So equals to 3. Or we can do it by a calculator here. We have log 8 divided by log 2, which is equals to 3. That's it. We have some ways to solve it, but let's solve it by our way, which is we have to divide them. We have log 7 and 49 divide by 7. Why we divide it? Because here we have a minus, so we divide these two numbers and our bases are equal. So 49 divided by 7 is 7. It will be log 7 to 7. We have a note: if the base and this number is equal or are the same, the result will be 1. That's it. This is quotient property of logarithms. For the third property, we have power property of logarithms. What is power property? Let me give you examples. To solve this kind of example, we have a rule. If we have a power here, we can move this power in front of the log. So it will be 2 log 381. We can solve this one individually because here we have a multiplication. We can solve this one individually. Let's do it by a calculator. It will be log 81 divided by log 3 equals to 4. Equals to 4. It will be 2 multiplied by 4. So 2 multiplied by 4 is 8. As I mentioned before, we can move this 3 to in front of the logarithm. Move it to here. It will be 3 multiplied by log 5 1 over 5. Here we have a note. We said that we can solve this one individually. We have to solve this one individually, then multiply it by 3. So we solve it individually. We have a note here, log 5 with its reciprocal, so equals to -1. So it means 3 multiplied by -1. 3 multiplied by -1 is -3. This is how we solve it. Let's go to the check it out examples. Move this 4 to in front of the log. It will be 4 multiplied by log 10. So basically log 10 equals to 1. It will be 4 multiplied by 1, and 4 multiplied by 1 equals to 4. Repeat the steps. Move 2 in front of the log. It will be 2 multiplied by log 5 and 25. As I mentioned before, we have to solve this one individually. It will be log 25 divided by log 5 equals to 2. Or by a mental math, we can say 5 to the power 2 equals to 25. So 2 multiplied by 2. The result of this one equals to 2. Then 2 multiplied by 2 equals to 4. We repeat the same steps. Move this 5 in front of the log. It will be 5 multiplied by log 2 and 1 over 2. Here we have 2 and it is reciprocal. This log will be -1 equals to -1. So it will be 5 multiplied by -1. 5 multiplied by -1 equals to -5. It's very easy to solve logarithms when we know the properties. Let's move to the fourth property, which is inverse properties of logarithms and exponents. The property is simple. We know that if the base and this number are equal, the result will be 1. But what if we have a power if we have a power immediately equals to its power, they will cancel each other. If we have a base like 10, 8, no matter what number is, and we have the exponent, if the exponent is logarithm and the base of logarithm with this base are equal, they will cancel each other, this 2 is remaining. The fourth property is simple. Let me explain it by solving examples. To solve A, we can use fourth property, which is inverse property. Here we have this base is 8 and here is 8. So these two will cancel. The remaining one will be our answer. So 3x plus 1 is remaining. 3x plus 1 is the result. That's it. To solve this one, we can use the fourth property, or we can immediately solve it by a calculator. It will be log 125 divided by log 5, which is equals to 3. We don't need to use any property, so immediately by the change base property, which is log 125 over log 5 equals to 3. That's it. For the last one, C, this base and the base of logarithm are the same. So these two will cancel. 27 is remaining here. The answer will be 27. That's it. It is very easy. For check it out examples, when you apply the rules, it will be very easy. As we know that here we have a base 10. If it is not written, we have base 10. This base with this number are the same, so they are going to immediately cancel each other. So we have 0.9 as a remaining. So 0.9 will be our result. Here this 2 with our base are equal, so they will cancel each other. 8x is remaining. 8x is remaining. For the fifth property, we have change of base formula. We have two methods, method 1 and 2, but the easiest one is method 1. It said evaluate log for base 4 and 8. So example 5. So how can we solve this one? We cannot solve it by mental math, so we are going to use the fifth property. And we used this property in the previous videos, in the previous section, which is logarithms. The rule said we have changed it to this one. Log 8 over log 4. We studied before, so it will be simple. Log 8 divided by log 4 equals to 3 over 2, and 3 over 2 will be 1.5. So equals to 3 over 2 or 1.5. They are the same. For check it out examples, immediately we can apply the rule log 27 over log 9. By the rule, it will be log 27 divided by log 9 equals to 3 over 2 again. So 3 over 2, it means 1.5 equals to 3 over 2 or 1.5. For this one, for branch B, we have log 16, use the change base rule, and log 8. Immediately we can use a calculator. We have log 16 divided by log 8 equals to 4 over 3 or 1.33 equals to 4 over 3. That's it. This is how we solve the examples. Let's solve some more exercises about the previous examples that we solved. Example 1, 2, 3, and 4. We are going to solve the hardest one. So we have exercises. We have number 1 and 2 and 3. Those are easy, but let's solve number 2. Our bases are the same. We have 10 here and 10 here. If it is not written, it means we have 10. So we can multiply these two numbers together. It will be log 100 multiplied by 1000. It will be 100,000. So by a calculator, immediately, because we don't have a base here, it means it is 10. We can solve it very easy. Log 100,000 equals to 5. That's it. We have log 3 and 3 multiplied by 27. Why? Because we have a plus and our bases are the same, so we multiply these two numbers together. So 3 multiplied by 27 is 81. To solve it by the fifth property, which is log 81 divided by log 3. You can skip this step, but I will do it. Log 81 divided by log 3 equals to 4. That's it. This is how we solve it. Let's go to example 2. Example 2, exercise 4, 5, and 6. Let's solve 6 because I think it is the hardest one. Let us solve it. The bases are the same and we have minus here, so we divide these two numbers. Log 6 and 496.8 divided by 2.3, which is equals to log 6 187.9 or 92. Log 187.9 divided by log 6 equals to 2.9. If you see here in example 3, it says simplify if possible. You have log 8 and base 8 and 8 to the power 2. We can cancel these two and 2 is remaining. In exercise 8, these two will cancel because they are the same and 5 is remaining. That's it. For number 9, let's solve it here. We can rewrite it like this. Log 7 and 49 is 7 to the power 2 and to the power 3. We know that between them is a multiplication. It will be log 7 and 7 to the power 6. So these two will cancel. Just 6 is remaining. So our result is 6. Here we have a power. We can move this power in front of the block. It will be 4 multiplied by log 1 over 2 and 0.25. We can solve the yellow one. We can solve this one by a calculator. How? Like this. Log 0.25 divided by log 1 over 2. It should be in the brackets. so it equals to 2. So 4 multiplied by 2 equals to 8. That's it. For example 4 is also the same. This base and with this base are the same, so we cancel them and equals to x over 2 plus 5. This is our answer. And in here, this 2.5 with this 2.5, they will cancel. Just 19 is remaining. In here, we can solve by a calculator. And 14 is also, we can solve it like the 10. They are the same. For example 5, the 15, I think it is difficult, but because we are going to solve it by a calculator, it will. So by this rule, log 1 over 27 divide by log 9. Let's use our calculator. Log, you have to write 1 over 27 in a parenthesis. 1 divide by 27 and close the parenthesis, then divide by log 9 equals to negative 3 over 2. Equals to negative 3 over 2. You can solve 16, 17, and 18 like the same way, which is 15. Let us solve some hard examples. Let's solve one more examples, which is 43. So log 1 over 2, it will be negative 1 plus. We can move this one to here. It will be 1 over 2 log 1 over 2 and 2. Again, the same process. That one will be negative 1. It means negative 1 plus 1 over 2 multiplied by negative 1. Negative 1 multiplied by 1 over 2, which is positive, it will be negative 1 minus 1 over 2. So it will be negative 3 over 2. You have to equalize their denominators. Look at 44. This 7 with this one are the same, so they will cancel. 7 here is remaining, minus. These two are the same, so they will cancel. This 7 is remaining. 7 minus 7 equals to 0. For 45, as we know that we have 10, so they will cancel. We just have 10 for numerator. And also that one is 10. 10 with the base of 10 are the same, so they will cancel. 10 is remaining. 10 divided by 10 equals to 1. We finish section 4. Thank you for watching.